This is 6.1. We are dealing now with exponential growth and decay functions. So the essential question is, what are some of the characteristics of the graph of an exponential function? So, oops, if I can pick that up. Let's start off with some essential vocabulary since we're new to these exponential functions. So you might want to know what one is. It is the function y equals ab to the x power. A cannot be 0, and the base b is a positive real number other than 1. When we graph these, we get this thing called an asymptote, and that is a line the graph approaches more and more closely but never actually touches. It looks like it does, but it doesn't. We'll have exponential growth functions, and these are functions where a is greater than 0 and b is greater than 1. And that growth factor is b when you have when you have an exponential growth function. We also have exponential decay functions, and that's where, again, a is greater than 0, but b is between 0 and 1. You can kind of think of growth and decay as our stretch and shrink, the same rules. If it's greater than 1, it gets bigger, so it'd be growth. And if it's between 0 and 1, it got smaller, which was decay. Okay, and that decay factor is just the b. So if we go back to these functions, the growth and decay is just dealing with whatever's taken to the x power, that base of b. Okay. Excuse me. So now let's talk about some core concepts here. So we talked about, let's start with growth here. An exponential growth function, the parent function for it. Okay, the function will go through 0, 1, no matter what. And then it goes through 1, comma, b. So if it's growth, that goes up here. If it's decay, that's between 0 and 1, so it's going down, okay? So I like to think of this as, you know, you start off little and you grow up. So that's the growth part. And if you look at this graph, it looks like it is touching that x-axis, but it doesn't. This would be the asymptote right here. It is never actually going to touch that x-axis. It gets closer and closer and closer to it, but never actually touches it. Okay? And then the decay, like I said, it's when b is between 0 and 1, so you get that point 1b. So it starts tall and it goes back home. So you can think of this as when you're an adult and you have money and your funds decay, you're going to end up going back home to parents. So you get closer to your axis there. All right. So let's give a couple problems a try. So we are going to tell whether the function is exponential growth or decay, and then we're going to graph it. So starting with number 1. Okay, we have y equals 2 to the x power. All right, so we want to know what b is. In this case, our b is 2, because that's what's taken to the x power. That is greater than 1, so I know that this is a growth function. It's exponential growth. We always have the point 0, 1. And then we have the point 1b. So if you want to write those down so you know you have them. And our b was 2, so we have the point 1, 2. Now, if there's pluses and minuses, this obviously moves, but we're not dealing with that quite yet. If you want to put more exact points on here, you can just make a table and plug points in for x. Okay? But I'm okay with, and I like to draw the asymptote just so I remember where it's at. So when we start translating things up and down, it helps us. Anyways, I'm okay with just the 2 exact points. We know it starts small, goes through those points, and then it's going to go up forever. Okay? All right, number 2. Okay, in this case, our b is a 1/3. That is between 0 and 1, so I know this is exponential decay. So I plot those points. Remember, we have the point 0, 1 and 1, comma b. So 0, 1, And then B is 1/3, so I go 1 and up about 1/3. Here was that asymptote. And then it's going to start tall, go through those, and flatten out. Okay, it doesn't go back up. It is approaching that x-axis infinitely. So it's still going down, just very, very slowly. All right, number 3. This time my B is 7/2, which is the same thing as saying 3.5. All right, so that's greater than 1, so I know this is exponential growth. I'm going to have the points 0, 1, and 1b, and an asymptote. Okay, 0, 1, 1, and then our b is 3.5. So this one gets steep very quickly. All right. And then the last one for this part, B is a 0.8 that is between 0 and 1, so this is exponential decay. Whoops, let's put a box around it. We have the points 0, 1, and 1 comma B. So 0, 1, and our B is 0.8, and then we have that asymptote. So since it's going smaller to the right, I know I start up, whoops, go through the points, and approach that x-axis. Okay, it may be out here. Like I said, if you want more exact points, make a table and you can get those. All right, so your practice that goes, the problems that go over the graphing of exponential growth and decay are problems 1, 2, 10, 11, 13, 16, 19, and 20.